What comes to your mind when you say mechanics? Nothing comes? Yeah. Something mechanical, right? Mechanics means something kind of mechanical, kind of rigid things, right? And kind of moving stuffs, or maybe the forces. And I think you kind of feels the idea, but you kind of can't convert it to words, right? Mechanics means like the vehicles and all, and maybe the some rigid structures, right? Those sort of stuff. Yeah. So yeah, good. At least I guess you have a certain idea from the O levels, but here we are in the A level. So mechanics is going to be discussed under several subtopics. So for this part, we're gonna be learning. We're gonna split this one into several sections. The first one we are going to learn will be the linear motion, right? And the second thing we are going to learn is the force. Third one is the momentum, and the fourth one is going to be center of gravity. Yeah, okay, center of gravity. And fifth part is the equilibrium, force equilibrium actually, equilibrium of forces. Before that, yeah, it's better we could just sneak one into this one. That's the friction, and then the equilibrium of forces. Then we are going to learn work and energy, and the eighth part is going to be okay, so that's rotational motion, rotational motion. And ninth one is going to be uh, hydrostatics, statics, and fluid dynamics. Okay, you can see there basically around 9 segments, but each of these will be again divided into few of the subcategories. So if you just consider about the force, it will be consisting of like Newton laws, as you heard, right? The guy who's fallen an apple to his head, and the laws he given, right, related to the force. And also apart from that Newton laws, we are going to learn something called normal reaction, impulsive force, likewise. Yeah, different sort of forces also we are going to learn. Likewise, we are going to deal with mainly these 9 sections for this mechanics. And as I told you before, and you know this one, mechanics is going to be the lengthiest unit in the syllabus. So it is consisting of 110 periods. So each period is going to be, the normal school periods, that is 40 minutes. So you're gonna get here like 4 and 2 zeros here, minutes, and divide by, you can divide in the second 60 to get it in hours, right? So almost like roughly it's 42, which means 7, right? Yeah, 7, 42, 20. So again, 3 something for 73-ish hours will be going on to finish up this entire mechanics part. And this is including some practicals as well. And why we supposed to learn this one? You might be wondering. Well, yeah, basically for the exams. So when we come to the exams, there will be, the MCQ paper. So for the MCQs, there will be around 5 to 6 MCQs are there. And in the structured question, I once gave you the paper structure, the the ultimate giant the ultimate dragon that we are going to face at the very end, right? That's the exam. So in the exam, we're gonna have a structured paper, which is paper two, and this is paper one, which is MCQ. So paper two, we're gonna have two parts. Part one is the structured essay, right? In the structured one, we are going to learn. We need to answer the 4 questions that are related to the practicals, and you need to write within the paper. There will be the spaces provided. So for this very first question, you will be given a question from the practical that we are going to learn for the mechanics, which which you can score uh, 20 marks. So each of these question will be 20 marks, right? This is 20 marks. And in the part 2, it will be the essay one. So in the essay one, again, the fifth question, 4 questions comes for the first part A, part 1. And for the part 2, starting with the fifth question all the way up to 10th question. So you can choose 4 out of these, right? There will be 6 questions, you can choose 4 out of that. And the fifth question is definitely going to be like from, I think from the day this A level started, maybe 90s, early 90s, right? From there onwards, the very first question in the essay, this fifth question could change according to the way it is given earlier, but recently after the 2010, this hasn't been changed up to now, which is for the previous year, 2024. The essay question, first essay paper, first question, which is the fifth question, is from the mechanics. So mechanics will be again, here in this part you're gonna have 30 marks. So 30 plus 20, it is altogether 50, right? 50 marks. But this mark will be divided by 4 because this is for the 200. This 50 is from 200. So you need to find it with the 200. That means each of the mark for the paper 2, the marks will be given out of 200, and that is being divided to 4 to get it with 50, and that 50 will be added straight away to the MCQ 50, and there will be 50 MCQs. So from that 50 we're gonna get for the maximum 6, but let's say it is to be okay, we'll take it to be 6. Okay, 6 MCQ, so directly 6 marks are coming from here, and out of 200 you're gonna get 50, which means this has to be divided by 4, right? Yeah, they are getting 200, so we should divide it by 4, which means 50 divided by 4 is what? 12.5, right? So 12.5 plus this 6 marks, which is going to be 18.5. You might say it's not much, but this 18.5 can make 70 marks to 78.5. This is a B, and this is going to be an A, right? So out of 100, 18.5, around like almost 20, means 1/4 of the entire mark that you can get for the paper, right? So it's a huge lesson. Also, we can score more marks out of it, and we can think of it's like mostly involving some other future lessons too. If you consider about the 10th lesson, the mechanical properties of materials, there also we need to deal with some sort of force stuffs. And for other things like the thermal physics, the fourth unit. There also we need to include some part of the linear motion and the force and the friction too, right? And also some equilibrium parts. And yeah, different future lessons are going to be also involving in the same mechanics lesson. So you like kind of have a good institution, right? To make this lesson to be kind of you can pioneer with the lesson, right? Okay, great. So with that being said, we'll write the big topic mechanics. Mechanics kind of a length, like a large topic, and if you are using in a color, you won't be able to use it until 6 months because we're gonna be continuing this lesson around 6 months. Great. So we write a little note, right? Like describing what is this mechanics. We write as we have discussed in the first lesson. As we have discussed in the first lesson, as we have discussed in the first lesson, there are physical parameters or physical quantities. There are, first lesson, there are physical quantities that can be measured, that can be measured directly or indirectly. Directly or indirectly. Out of them, out of them, the parameters, the parameters relevant to relevant to mechanical measurements and calculations. Mechanical measurements and calculations are considered in this unit. Are considered in this unit. Okay. Underneath we write the next point. Those are discussed under 9 under 9 sections. Under 9 sections. Okay, so we write these 9 sections then. I think the table is a little bit shaky, right? Just hold on. Okay, now it works. This is equilibrium of forces. This is hydrostatics and fluid dynamics. Fluid dynamics. Okay, great. Then we write a subtopic. From here onwards, we are going to learn about the linear motion. Next subtopic is the linear motion. And don't worry, we are going to learn some basic things that we have already learned for the O levels, like the distance, displacement, and those sort of sticks in the beginning. Okay, right. A little note again. If the position of an object, if the position of an object, if the position of an object change with time, change with time, the object is considered to be moving. Object is considered to be moving. There are different motions in the universe. There are different motions in the universe, such as linear motion, comma, rotational motion, linear motion, comma, rotational motion, and comma, simple harmonic motion. Simple harmonic motion, dot dot dot, etc. Next point, right? If an object moves in a linear path, if an object moves in a linear path, it is a linear motion. It is performing a linear motion. It is performing a linear motion. It is performing a linear motion. Next point, right? Let's consider the physical parameters. So, as I told you, like you learned it for the O levels, the very first thing we are going to learn is of the distance, right? Let's again have a quick idea about what if an object is moving. Now, is this object moving? If I just hold it by my hand like this, is it moving? No, right? So, which means you can see over the time it stays on the same position. But if the position changes with the time, and maybe in the first second, like the moment we are going to observe the object, it is at here. Maybe after 1 second, it may have gone to here. After 2 seconds, it is at here. Which means the position of the object changes with the time. So we're gonna say to be the object is moving. So there could be different types of motions, like in this case it is just moving linearly, or maybe it could be like this. Here also the position changes with the time, but now it is going in like a circular path, right? In that case, the last mode it wasn't going in a circular path, but you know, right? If it is going in a kind of fixed, if it is going in a path where it has a fixed distance to a certain point, we can remember the locus of a point, equidistance from a fixed point. Here is my fixed point, and this is the locus of a point, right? Locus means a path. So it's a rotational motion then. And there could be some scenarios like this. Maybe this bottle right here, and which is attached to a string, and I can wave it like this. You can see with the time the position changes, right? Don't get hypnotized. So in that case, you can see it's kind of oscillating actually between two fixed points, like here and another point here, right? It's just going back and forth between two fixed points. So we're going to say this to be a harmonic motion or a vibration, right? So there are different types of motions that we can see in the real life. Out of that, we are first going to consider about, don't worry, we're going to consider about the other things too, right? There was a part called rotational motion, which we are going to learn about the rotations. And not in this lesson, in the third lesson, the waves and oscillations, we are going to learn about the simple harmonic motion. And that's why this kind of a weird bottle is in there, right? To show you this, show the students how the things are working. Okay, so anyhow, uh, out of that, the linear motion we are going to discuss first. So there, we know if an object is moving, it will covering up a certain distance, or it will covering up a certain length in the path it moves with a certain time. So we need to discuss with the distance and also the displacement. So we write a subtopic then, another subtopic, so that is the distance. These are basic O levels, so what does it mean by the distance? Distance. Yeah? Yes, the length of the path between two points, right? Okay, so we write distance. The length of a path, the length of a certain path length of a path, a certain path, length of a certain path, which an object moved during the motion. During the motion. Okay, so the full stop, full stop. And what can you say? It's a scalar or vector? It's a scalar. Yes, it's a scalar there. This is a scalar quantity. You can write to the same point or maybe in a new point. This is a scalar quantity. What's the SI unit of measuring the distance? Yeah, there are dozens of units, millimeters, centimeters to measure length. Out of that, kilometers, right? We are going to use meters as the SI. So you can write there SI unit meters. Great. Second subtopic. That's the displacement. So what's displacement? Yeah, the shortest possible distance between two points. Okay, we're right. Displacement. Uh, the shortest possible distance. The shortest possible distance between the starting point. Shortest possible distance between the starting point and the ending point. Starting point and the ending point of a motion. Is it a scalar or vector? Said to be a vector. Okay, this is a vector quantity, and again SI unit is meters. Okay, to be clear enough, we have once considered about this one. Let's consider about 2 points. Maybe from your home to this institute. I should draw it the other way, right? The institute is kind of lower here, especially coming from New Delhi, right? So this is the institute. Okay, so this is your home, right? So the furthest person is Nushka again, right? So uh, once I taken this example, let's say she's coming to Bandaraville, so she can follow many paths. Right? You can just come from maybe to the Nuvarelia, then after the Capitol, I guess, then from there to Valimada, and to the Bandaraville from this path, maybe, right? This will be around 42 kilometers, right? Or maybe you can just come to the new area, then to the capital, then after you can go to the Borland, then maybe to the Hapudale, and you can come by that road and Hapudale to that up road, right, and come into the Bandara. This will be again a little bit greater than this. It's going to be around 48 or 49 kilometers. Or maybe you can come to here, again to New area. Then after maybe to the valley, and there's another road from Adampitia and all the way and coming to Bandara, right? And this will be around like 58 or 59 kilometers. That's right. I'm just giving some rough values. You can see here there are different paths that you can follow when you are coming to 2 points. Let's say your home is not at the Nandipur, let's say it is at Valimata for an example, and here the institute is at Bandaravilla, so kind of here, right? I'm just simplifying the concept. So you can see there are like different paths between these 2 points, your home and the hometown, I mean the town, right? Town where the institute is. So in that case, following each of these paths will gives a different distances. So distance is basically the length of the path that you follow. Not you guys, if it is an object, it could be the length of the path that the object has been followed. But again, let's say Nushka is very rich enough, so she has her own helicopter. So in that case, she can just fly up You don't need to follow the bus road, right? You can just lift it up, take it off, like that, and like that, come to here, and maybe you can land on the rooftop of this building, right? Or maybe here. Maybe you need to land for the MC ground in Bandarwala. In that case, you don't need to follow none of these paths. Instead, you can just cover it up, starting from here all the way up to here, right? In that case, you should have a certain idea how long you need to go, which indicates the magnitude of the displacement, and also you need to fly into a certain direction. Otherwise, you will end up with maybe Kielnochi, right? Somewhere else. So you need to have a proper direction. The helicopter need to be turned, and you take it off, and you need to turn it exactly. So once I told you from the north, you can measure up a certain angle, which is said to be a bearing, right? From to the clockwise direction, and you just take it off, turn it to the clockwise direction, whatever the angle, and you can fly it straight away, so you can come to the Bandara, right? Likewise, let's say, even though it is around this much of kilometers, let's say let's take the Hapudale road, which is around 49 kilometers. I'm just taking off the other thing. You can follow this path, which will be 49 kilometers, but straight away it's going to be just around 8 or 9 kilometers, right? Probably 9 or less kilometers from there. So this is going to be what I have shown in the red color is the displacement between the 2 points, and this right here, the 49 kilometers, is going to be the distance. Okay, so we'll just have a quick summary on them. Draw with this uh, diagram, but you don't need to draw the helicopters and all those sort of things, right? And then all those. So you can simply write 2 points A and B, or maybe A and B here. This is A and this is B. Just draw any random path to the distance. Okay, great. Now I told you when something is moving or in motion, its position changes with the time. So you can consider how much of distance or how much the position has been changed or the length of the path with respect to a certain time. For example, if you are like coming from Nuvareli to here, it will be taking around 1 hour and 30 minutes, I guess. No, more than 2 hours. Okay, I think you are like coming from the slowest bus then. Okay, so uh, 2 hours, okay, 2 hours and 30 minutes. Oh, okay, okay, great. So I think it's not going to be a big deal for you, right? It's just around 10 minutes or 15, I guess. Yeah, okay, 15, we'll say. So the distance will be around 42 kilometers from there. So I can consider the time, and within that time how much of distance it is being covered, right? This is the distance, 42 kilometers, let's say. So to cover up this distance it takes this time. So you can describe a meaningful parameter here, which is the speed of yours, right? So here it is 42 kilometers. Maybe I can convert it to meters, because meters is going to be the SI unit. I can multiply it by 1000. this thing right here, 2 hours and 30 minutes means entirely it will be 120 and 150 minutes, and I can convert it to seconds because the standard SI unit of, I mean the SI unit of measuring the time is seconds. So I can multiply it by 60 again. So these cancels off. 642, that is 7, right? So 70 divided by 50, which is around, what's up to then? Mm, 5, no, 75. It is for me. 2 zeros, 60, 10, 100, 6-ish, somebody, right? So it is 4.6 meters per second. We just consider 1 second, it goes 4 meters, whatever the vehicle that you come. Right? Let's say for your case, how far from here to your home? Okay, let's say 3 kilometers then. Divide by 15 minutes. So it is 3000, which is a pretty good divisible value, right? So it is 50 into 60, like this. So, okay, I can just cancel it by 5 then. This is then 200. Oops, my bad. It's 50. So divide by 5, that is 10 over 3. Okay, so still you're gonna have like 3.3 meters per second, right? So you're gonna see it's, even though you're gonna have a very shorter distance, it takes a lesser time, but if you consider about the speed of yours, it's going to be not much with this speed, right? Because the newer relay buses are going to be faster. Not especially there, but when it closer to the bandara, right? At the very last point. So yeah, you can see I can we can describe a certain meaningful parameter here. What's the speed? Which means the distance it can cover in a unit time. So we write the next topic, speed. All this we have learned for the O levels. I'm just giving you a recap. We write uh, the distance covered by an object in a unit time. The distance covered by an object in a unit time. A unit time means 1 second, right? Okay. So if it is something considered with the if you consider something with the time, guys, what's the parameter that we can say? If something is, some change is considered with the time, yeah, we can consider it to be a rate, right? So you can say if you just open a tap, the water flows out, so that's the rate of flow of water, maybe. Or maybe like you have seen, if you just take a book and check the price of that, maybe 2 years back, let's say it is 280 rupees, right? Now it is maybe 560. So over how long? Over 2 years. Okay. So you can maybe consider this like change the, like having the change here. Of course, you can subtract 280 from 560 here and divide by 2 years. So you can say how much of the increment of the price for a year, the rate of increment of the price. Also, you know that the value of a rupee is eventually decreasing. So that's called the inflation, right? So don't worry, we don't need to learn about it for the physics, right? But that's something called inflation. So there's a rate of inflation. Recently, it was a very huge value, but now it's kind of getting settled. So anyhow, something with the rate means we are considering with the a certain change with the time, right? So you can consider this to be the rate of change of distance also. We'll write in the next point. This is the rate of change of distance. This is the rate of change of distance. Great. Now you already know the equation. So speed, you can write along with me. Speed equals distance traveled divided by time taken. So the SI unit is meters per second. We're wondering how it came. This is in meters, this is in seconds. So seconds come up per second. Yeah, that's how it made. Meters per second. What about the dimensions? Yeah, this is meters, so L. This is seconds, that is T minus 1. You know, we can quickly derive the dimensions if you already know the units. Okay, let's go to the next one. If I just change the same thing with the helicopter's example and the displacement, again measured in meters, but now you know the displacement is the shortest possible distance and it is a vector. In that case, this is going to be the velocity. So we write the next subtopic, velocity. The rate of change of displacement. The rate of change of displacement is defined as the velocity. Defined as the velocity. Okay. So we can write the equation once again. Displacement divided by time. Time taken. Just time. So again, unit. I know this is a kind of boring, so you just write it straight away. Unit meters per second. Dimensions LT minus 1, and right afterward, this is a vector quantity. It's a vector. Velocity is a vector, right? Right. So more importantly, we are going to use some standard symbols here. Usually for the displacement, we are going to put displacement. We are going to put a letter that is simple S. This is not standing for the seconds. If you write the seconds, we can just draw some two lines, right? To show that it's a second, basically it's the same S. But here it is the simple S we just use for the displacement. I don't know why, but that's how it is being used in the syllabus. So the velocity, we can use a term called simple U, and for the time, we are using the T. So let's replace with the given standard symbols. So velocity is U, that's equal to displacement, that is S, divided by t. So you can cross multiply this t to the other side, and I'm gonna have ut equals s. So s equals to ut. So you can have this as a certain equation that you should remember. Also, you need to remember this too, right? Which is something you have learned already. So I guess there's no issue with that. But this you need to remember. Underneath the right, after you get this equation, මේ equation එක ගත්තට පස්සේ ලියන්න. This equation can be applied. This equation can only be applied. Right. This equation can only be applied uh, when the object moving in a constant. When the object is moving in a constant, or within bracket you can write uniform. Constant uniform velocity. Great. Let's do one question. Writing the notes will be boring, right? Okay. We'll consider like this. Example 1. A child follows a path from A to D as shown in the figure. This is the child. Okay. So he's following a path from A to D, and we'll just sketch it. Okay, we write the first part then. It's going to be having several parts, so we write the first part. Maybe Roman number 1. Calculate the distance traveled. Okay, we'll do it now. It's easy peasy, right? So 120 plus 60 plus 40, 220 meters. Okay, next part. If he took 20 seconds to reach D, to reach capital D, calculate the speed. Yeah, that's 11 meters per second, right? 220 divided by 20 seconds. Okay, next part. Calculate the velocity. Calculate the velocity. Okay, calculate the velocity. To calculate the velocity, we're supposed to know the displacement. If it rings a bell, that's the shortest possible distance between, shortest possible length between the starting and the ending point. Starting point is A and the ending point is D. So this is the displacement. That's the S we need to find out. Well, you can pretty much do it with the given length, right? So maybe have a triangle like this, because in order to apply maybe a Pythagoras or whatever thing, you should have a right angle triangle. Yeah, I have constructed one. So this side is also 60. This is 40. So what can I say about this side? It's going to be 80. Okay. If you are like pretty familiar with the Pythagoras triple, this is 6 and this is 8. What's the other side? It has to be 10, which basically here 100 meters. If it is 80, 60 and it is 100, 86 and it is 10. Or else you can use the Pythagoras theorem, like x squared is equals to 80 squared plus 60 squared root. Oh, yeah, okay, fine. So yeah, you can have here 10,000 and root, that's 100. That's the displacement. So you can use that equation, maybe S equals ut there, or maybe the usual equation is velocity equals distance displacement divided by time. You can use that too. And here it is 100 equals u is the thing you should find out. And still it took the same 20 seconds to reach the D. But the actual displacement is 100. The distance will be 100, 220. So u is basically 100 divided by 20, and that is 5 meters per second. Not really for this one, but later you need to. We are going to learn some special, like there are 5 formulae that are related to the linear motion, and it's better you could write once we learn about them. And specifically you need to mark a direction too. Here also it's a vector, right? So we need to show a direction, or you can say it's the alpha here and find out the tan alpha, or maybe at least you can just show that it is to be aligning from A to D, and S equals U will apply to that direction. Always we need to do the pair, right? It's a vector, so we need to say both magnitude and direction. Either you can find out the tan alpha, or we at least just show it with an arrow to that side. Right? Have the practice, not for this one basically, but later on we're gonna learn deal with whole lot of things moving to here and there, like maybe one is moving to left side, the other one is moving to the right side, maybe up and down. In that case, whatever the equation that you apply, it's going to be involving vectors, and we have finished that lesson already, so we need to mark the direction too. We'll have the practice from the beginning, that's why I just draw some arrows here. Okay, great. So yeah, we'll move to the next example, question 2. Are you good with this? Okay, great. We try the next question. The motion of two cyclists. The motion of two cyclists in a linear road is shown in the figure. It is a there's another cyclist here, B, which is around let's say 10 meters. Yeah, okay, 100. Put a divisible value, so it is 100 meters, and they are riding two bicycles. This is B. Draw. So let's say this right here is moving with 15 meters per second, while the A here kind of chasing the B, moving with 20 meters per second. Okay. So with these velocities, what can you say again? A is riding faster than the B, but initially they gonna have this separation in the at this moment. With this velocity, what you can say about the motion of A and B? Like that, right? Eventually, the A will have a chance to pass the B because the velocity of the A is higher than the B, right? And that's the question, right? First part. Find the time taken for the A. Find the time taken for the A to pass the B. Next part. The next part, right? Find the displacement of the B by then. I think that the space that you have kept is not sufficient for all of you guys, but I thought maybe you are writing the question 1 and 2 closer. It's okay, it's okay. Yeah. Uh, find the displacement of the B by then, or by at the moment the A passes B. Oh, nice. Tanuji has found an easier way to do that, which is from something called the relative velocity, which we can learn in a future lesson. Or else we'll stick to the procedure for now, right? Because we don't know about the relative velocity yet. Do you know about it? Oh, yeah. Okay, great. So let's stick to the old-fashioned way, which means they're gonna meet somewhere here, right? We don't know where it is. Somehow, at a certain time, the B will cover up this distance. In the meantime, the A has to cover the 100 and whatever the distance traveled by the B, because B is not at rest here. B is also moving, A is also moving. So at a certain moment, they're gonna meet. So they're gonna meet means the displacement covered by them has to be equal. If the B is not moving, then it's pretty easy. Okay, we have this B which is stationary, so the A is just moving. And that's what we are going to do in a future lesson. That's called the relative velocity. We're gonna freeze the B, not by the Shita Bhuta, right? Like that, right? Freezing means we're gonna stop the B. That we can do later on. For the time being, B is moving, A is also moving. How far the B has moved? Maybe here, right? Starting from here, I can mark it to be the SB. Isn't it so? How far the A has to go to pass the B? He also need to follow same path, but whatever the displacement of the B plus there was this additional 100 which was in the start, right? A යනවා නම් A B ව pass කරනවා නම් B කියපු displacement එකත් cover කරගන්න ඕනේ. තව additionally 100 meters තිබ්බ කලින්. ඒ ටිකත් cover කරගන්න. So this will be the SA all the way up to here. And we're supposed to find the time. And let's do an assumption. Let the time taken T. Then I can consider for the A to this side S equals ut. Because you can see here the velocity of the A is not changing, so it is 20, right? All the time it's just 20, the same value. So this is SA, it is equals to 20 into T. We have taken at the time T, they're gonna meet. So it has moved a distance of 20 into T within that time, which is the SA. Also for the B, for the B to this side, S equals ut again, and that's SB equals ub, which is 50 into T. Okay guys, so we have taken two relationships with the velocities and the time. We're supposed to find the time. What's the relationship between SA and SB. SA and SB. Yes, or else you can say SA right here equals to 100 plus SB, because A has to move whatever the displacement of the B plus this initial 100. So you can, for the SB you can use 50T, and this is 20T, and that's equals to 100. What do you need to find out? It's the T, no? So you can take this to the other side, so it is going to be 20 minus 15, T is common, and that is 100. So this is 5T equals 100, and T is equals to 20 meters per second. Sorry, 20 seconds, right? Okay, that's how we find it. Again, for now, we can use this kind of a theory, but later on in advance, we are going to learn about something called relative velocity. We are describing a velocity relative to another moving object. In that case, it will be very easier. Well, let's stick to the basics. Right? Sometimes you won't be able to apply the relative velocity. Moreover, if something is accelerating. So better you mark the SP and SA in your diagram, right? Represent somewhere they're gonna meet. For a dotted line setting adala තියාගන්න. Okay, great. So we're supposed to find the SA and SB too. Didn't I mention that? No, right? Yeah, I have mentioned. So find the displacement of the B by then, which is you need to find the SB. Simply you can use this equation again. So SB is equal to then 50 into T, that is 20. That's 300 meters. Make sure you write the unit, otherwise you will get marks for maybe writing the equation and put in the put in the substitution. This is to be 1 mark, and there's another mark coming from the last answer, but if you are written without the units, you can't score that one. So make sure you write the unit for the final answer. But for the chemistry, you need to write the intermediate units as well while simplifying, and you should supposed to show how the units are being simplified there. But for the physics, you don't need to, right? You don't need to show how the units are simplified, which means you don't need to apply it for the substitutions. But for the final answer, you need to definitely write the units. Okay, great. We'll move into the next part, and that is called the average velocity. Next subtopic, average velocity. We should finish with this. I finish with this. Okay, great. average velocity. Oh, you can maybe put a slash and write average speed. That also works, right? Sometimes you can say it to be average speed. But we know the velocity and speed are two things. What is this average velocity or average speed is? Any clue? No. Average means something average. I think you have learned it from O-level maths. Average or mean, something like that. Or median. Yeah, yeah, that is it. You just have it in the mind, but can't turn it to words. Yes, yeah, yeah, good. So something giving a middle value, right? Some sort of a generalized value for a set of data, right? Kind of like that. So the earlier calculation that we did, maybe coming from no relative here, we have seen the velocities to be 44.6 meters per second, right? So the more convincing unit is going to be not in meters per second when it comes to the vehicles and the speeds. It's going to be in kilometers per hour, kmph. I think you have seen with this. It is there, which is printed in a meter in those vehicles, right? For every vehicle, they have something called speedometer. So it's basically showing the speed, and it is said to be in kilometers per hour, which you can calculate very easily. I have taken there 42 kilometers, and you told me it is taking 2 hours and 30 minutes, right? To be kind of divisible, I'm just removing on this 30 minutes, which let's say the bus came faster. So in that case, you can take it to be 21 kilometers per hour, okay, mph per hour, right? So, which is a very slow speed, by the way. So, the vehicles are usually going with 60 kilometers per hour. This is the safe speed that a vehicle can move in a general road in Sri Lanka. But when it comes to the highways, we can go up to 100 kilometers per hour, right? And this value is kind of a small value, but yet, tell me, guys, is that the bus coming from there to here traveled at exactly this speed over the entire distance? No, right? The bus was kind of speeding or maybe stopping for the passengers to leave out from the bus. In that case, there will be some different velocities over the time. But we're gonna say a rough value, okay, it's 21 kilometers per hour. But it could be coming faster in some sort of ranges, maybe closer to the town, or coming slower at the moment it started. Likewise, the velocity fluctuates or changes, but here we have defined is something an average value. So you're gonna see here, if I just write the equation average velocity, so average, we can write it to be distance also. If you consider about average speed, it's going to be distance. In average velocity, it's going to be displacement. So I'm going to write with the displacement. So we can write total displacement, which is this 42 kilometers, right? That's the total actual distance that you have traveled in that case. Divide by the total time it takes. Total time was just 2 hours. But in between the motion, it is not going with the actual this value. Could be changing, but we are just saying a rough value, right? Kind of average value for the entire motion. Okay. So this is the equation that we did, right? So we write a little note for this one. The average velocity, right? We write like this. The velocity of an object could change with time. The velocity of an object could change with the motion, not time, right? With the motion. The velocity of an object could change along the motion. The value for the velocity, average value for the velocity can be defined, can be defined at then, or we can write at this moment. We are writing in short, so an average velocity can be defined at then. So yeah, we'll straight away write the equation. Average velocity equals total displacement divided by total time. Okay, guys. So like if it is average speed here being asked, so it's the total distance divided by time. That's the only change you need to do. Let's write one example question. Uh, we'll take it with maybe a car, right? What's your favorite vehicle? Tanuj? What's your favorite vehicle? Okay, it's a car then, or maybe a jeep. A car. Okay, what's yours? Okay, it's a kind of a jeep. What's yours? Okay, it's a car again, right? Okay, so majority goes for a car then, right? But yeah, we can write anything, right? A car, maybe a Mercedes, or maybe a Defender, right? Whatever. Uh, moves with speeds. Moves with speeds 8 meters per second. 8 meters per second for 25 seconds. 8 meters per second for 25 seconds, comma 5 meters per second for 10 seconds, and 10 meters per second for 15 seconds. Calculate an average speed. Calculate an average speed for the entire motion. Okay. So asking the speed, so you can write the equation to be average speed equals total distance divided by total time. You can't just add all the velocities and divide by 3. In that case, it's not the average velocity, it's going to be a mean velocity. Right? There's a mean velocity means kind of like giving a middle value for the velocities. But the average velocity is we are considering the entire motion and kind of define a mean, kind of not a mean actually, average velocity again for the entire motion. And it's like mean and median in a different data set. So median you have found out like arrange them in the ascending order and kind of like middle value, right? That's kind of saying an average for the velocity. But when it comes to the mean, it's kind of like we are adding all the data and divide by the number of repetitions. In that case, it's kind of like a middle value for all the data, right? And sometimes the mean velocity and the average velocity could be equal, or sometimes it could be different. So I'm just replacing with the speed here, and this is distance. But you're supposed to know the total distance, right? Well, yeah, I can find it for each and every movement. Maybe for 10 meters per second, let's say it is s1. That's equal to 10 into 50, 15, 150 meters. For 8 meters per second, it's s2. I think this is the s1, right? Fine, this is s2, this is s1, as I have given in the order. That's 8 into 25, 200. And 5 meters per second, s3. That's 5 into 10, 50 meters. So all I have applied here is the s equals ut to this side. Of course, you can do it straight away, right? Maybe අපිට එකපාරම මෙතන ලියන්නත් පුළුවන්. Like this, 10 into 50 plus 8 into 25 plus 510 divided by, we can write like that, but I'm going to write like this, 150 plus 200 plus 50, and divide by the total time. So it has been taken 15 plus 25, which is 40, plus 5, that is 50 seconds. Yeah, it's 400 divided by 50. 8 meters per second. So for the reference, you can just add the velocities, 10 plus 8 plus 5. Yeah, okay. Divide by here, what you should do? Divide by 3 to get the mean value. In that case, it is going to be 23. Divide by 3, that is 7 point some value, right? And that's kind of different with that. So average velocity is not the mean velocity. Okay, great. Got it? Okay, great. These you need to find out displacements, distances, and total distance divided by the total time. Total time is 15 plus 25 plus 10. Great. Yeah. So we can move into the next one and we can have a quick break. That's what if the velocity changes with time. Or basically, if it is increasing with time, what we can say is to be an acceleration. Okay. So we write the next topic. acceleration. Acceleration. Let me write for that one. If an object is accelerating, if an object is accelerating, its velocity, its velocity should increase with time. Its velocity should increase with time. A new line, right? For an example, let's consider an object started from rest and moving with a constant acceleration now. And moving with a constant acceleration now. 5 meters per square second. 5 meters per square second. Okay, so you're gonna see here this is the object started from rest, which means I can write here the velocity is 0, right, at rest, and said to be moving with an acceleration of a constant acceleration of 5 meters per square second. What's the idea here, guys? 5 meters per square second කියන්නේ මොකක්ද? It's like you can have it like this: 5 meters per second divide by 1 second, something like that, right? So that means this second comes up and making the square second, right? Okay. So what does this one means? 5 meters per second in 1 second. Now this object is said to be accelerating. Accelerating means the velocity has to increase with the time. So with this parameter, what it says is, for each and every second, the velocity is increasing by 5 meters per second. That's the whole idea. If something is accelerating, we know from the O levels also, if something is accelerating, that means the velocity has to increase, right? And you know that once you like press there's a pedal called the accelerator, or maybe there's one, I can just turn it from the bikes and all, right? So once you press the accelerator, it's going to accelerate, hence the name accelerator, right? So which means the velocity has to increase. And more specifically, if there's an acceleration, usually we're going to mark with the simple a. If there's an acceleration of this much, that means for each and every second the velocity is increasing by 5. So if I consider some time lapse here, this is t equals 0 and this is t equals 1, t equals 2 and t equals 3. Yeah, it's better I could just draw another one here. I just maybe need to turn the camera a little bit to this side. Okay, great. That's my last point here, guys. Okay, great. So this is t equals 3 and this is t equals 4. And tell me, what's the velocity after 1 second. If it is accelerating with this value, yeah, it has to be 5 meters per second, because initially it had 0. After 1 second, the velocity has to increase by 5. That's the whole idea of 5 meters per square second. So it is 5 meters per second. What's the velocity has to be in the next second? Yeah, from 5, again, another second has been passed from 1 to 2. So there should be another 5 added to this. That is 10 meters per second. What about here? Yeah. So another 5 has to be added, so it is 15 meters per second. The next one, maybe to this side too, right? The arrow has to be larger, and that has to be 20 meters per second. Alright. That's how the acceleration works. Notice here I have drawn these gaps to be a little bit increasing. Why is it so? I could just draw it very closer, but instead I have kind of drawn it like this. You can see this gap, that's the distance or displacement within first second. This is the displacement within the second. This is the displacement with the third second, and this is the displacement with the fourth second. Why I have drawn it to be keeps on increasing gap. And even there. These two seems to be equal. Well, I can just correct it a little bit. But I'm right? Maybe here. Yeah, here. Fine. Think about it. Yep. Why? What if a certain object or vehicle or something like that has a higher speed or higher velocity? Higher velocity means velocity is the change of displacement per unit time. So higher the velocity means higher the displacement it can have. So slower the velocity or smaller the velocity, smaller the displacement it can go, right? So initially if I just work it like this, for a certain time I can go a little distance, cover up a little displacement here from all the way to here. But if I go faster, I can cover up a higher displacement, or I can obtain a higher displacement within the same time. You can see here guys, initially from t0 to t1, the velocity was just increasing from 0 to 5. So you're going to have lesser velocities there, and so lesser displacements. But eventually you can see here, now at this moment it is increasing from not 0 to 5, but now it is already having a velocity 5. From 5 to 10 it is increasing. So compared to the previous 1 second, the next second it is already having a velocity, so higher the velocity it can move into a higher displacement. If you see here, the displacement will be even greater because now it's starting from 10 increasing all the way up to 15. So if an object is accelerating, you're gonna see its displacement keeps on increasing with the time. Right? Higher the velocities, higher the displacement it can have. Smaller the velocity, smaller the displacement, right? Let's draw it. And you can write here underneath, right? Acceleration is 5 meters per square second, that is 5 meters per second in 1 second. Great. So having this idea, we can kind of make an equation, a proper equation to define the acceleration. What is that? Well, you're gonna see here 5 meters per second divided by 1 second, which means it's sort of a time. What is this? 5 meters per second? Each and every gap, you're gonna see that 5 meters per second, right? Which means from 0 to 5 has been increased, 5 to 10, and 10 to 15. If you subtract this from this, you're gonna get that 5. If you subtract this and this, you're gonna get the same 5. Which means it's the change of velocity. Change of velocity. Actually, that change is an increment here, right? It's always increasing the velocity. So change of velocity divided by time. How we can write it in words? Rate of change of velocity is the acceleration. So right underneath, rate of change of velocity is the acceleration. Then we write with the equation acceleration equals change of velocity divided by time. Right here, this is the rate, change of velocity divided by time. Rate කියන්නේ ඒක තමයි words වලින් ලියනකොට ලියන්නේ කොහොම rate of change of velocity කියලා. තේරුණා නේද? If you are writing in words, it is the rate of change of velocity. The equation is this, right? Okay, great. Uh, what about the opposite of the acceleration? The deceleration. Good. So, we are going to learn that. Let's try the next topic. Deceleration. Right. Let's consider an object decelerating. Let's consider an object decelerating with 2 meters per square second. Of course, the object is not shrinking down, right? It has to be the same size. Be very close like that. Okay, fine. Let's say now the object is moving with 10 meters per second initially, right? Now, what if there's a deceleration? Yeah, deceleration means the velocity has to decrease. So 2 meters per square second, and it is to be minus to this direction. You know the drill, right? It's kind of like 2 meters per square second means just 2 meters per second divided by 1 second, something like that. Which means each and every second, now the velocity is not increasing, the velocity has to decrease. So it is 10 meters per second, where t equals 0, when t equals 1, what's supposed to be the velocity? 8, right? 2 has been dropped. So 8 meters per second. You know, like when you're drawing these arrows also, it's better you could draw it to be proportional a little bit, right? Not to be like great, but at least to be proportional to t equals 3, t equals 4. Oops, yeah, okay, t equals 4 and t equals 5. Then you know it has to be dropping again by 6 meters per second, then 4, then to 2, and finally making it to be 0. Notice here again, I have drawn to be having decreasing lengths or decreasing displacement for each and every time. Why is it so? Yes, higher the velocity, higher the displacement. But it is decelerating like that, so decreasing velocities will decrease the displacement in each and every time. Correct? Okay, we're supposed to draw it once again. We draw. Okay, underneath we'll write then deceleration is the decrement of velocity is the decrement of velocity per unit time. The decrement of velocity per unit time. We can write in the next point, since it is the opposite of the acceleration, since it is the opposite of the acceleration, the same equation the same equation for the acceleration for the simple a, you can write same equation for the simple a over the acceleration is used, but with a minus to the considered direction. But with a minus to the considered direction. Okay, guys, so you can learn about it very soon. Like it's nothing but the same, like change of velocity It's again the same equation, change of velocity divided by time. But this change is going to be a negative value because you are subtracting 8, you are subtracting 10 from 8. Usually we take the difference to be final minus initial, right? So let's say price of a book, so 512 right now, let's say. Initially let's say it's 280. So you subtract the initial from the final to get the difference. So here also we are having this to be the final value and this is the initial value. If you subtract 10 from 8, you're going to get with a negative value here for the change of velocity. Right? It is said to be the deceleration, so you don't need to write the equation once again. It's just a matter of considering it to be a minus. The acceleration is minus in that case. I have drawn it correctly here. To this side, it is accelerating, but with a minus value, so it's a deceleration. You don't need to write the equation once again, right? Okay, so with that, we're gonna have the break, a little 10-minute break, and thereafter, we are going to derive some equations that can be used straight away for any sort of motion, if it is accelerating or decelerating or wherever, right? Okay. Alright guys, so now it's time for us to consider about some equations that we can use. You know what's physics, right? We are not just learning the things in a qualitative way. We are going to learn it in quantitative way, which means we need to have some measurements, some calculations. Actually, already we have learned some of the equations, and which doesn't sound like the advanced level, right? Because you have learned it from the O levels as well. So yeah, hereafter we are kind of deriving some equations again to be used for any sort of linear motion, right? So let's write a subtopic, formulae related to linear motion. Formulae related to linear motion. Formulae is the plural of formula, right? Which means we are going to derive few of them, not just one. For this, we are going to use some special notation, which means some standard symbols uh, to represent sort of parameters. When it comes to an object, now we already know we are using simple S for the displacement, right? And you know if the object is accelerating or maybe decelerating, you have seen that the velocity is changing with the time. It's not always the same value. Whereas the earlier one, if it is moving with a constant velocity, like let's say we have considered about the cyclist, right? The A was moving with 20 meters per second, as I can remember, right? So which this 20 meters per second will continue throughout the motion. So in this scenario, we are going to say it is moving with a constant velocity. Velocity doesn't change, or uniform velocity. You can get it from the word, right? Uniform or constant means the velocity doesn't change. If it is accelerating or decelerating, the velocity changes. And you can't just write u there. There will be a different velocity after some time. Let's say the same bicycle moves with 2 meters per square second, after 1 second, the velocity becomes 22 meters per second. That's all the idea of acceleration 2 meters per square second, right? Velocity has to be increasing by 2 meters per second and each and every second. That's the whole idea. So you can see there the velocity changes. So we need to define another term here, not just velocity, which we have used earlier. We can now consider this is the initial velocity. And this v, simple v here, to be the final velocity. And also for the accelerations and decelerations, we can put a there to be usually putting for the acceleration. But if it is a deceleration, you can put with a minus sign. That's all, right? And we need to deal with the time. So t is for the simple t is for the time. Okay, so these are the terms that we are going to use hereafter to define each of the parameters, right? Okay, so we already know that if it is moving with a constant velocity, if moving with a constant velocity, to this side we could write velocity equals displacement divided by time. So velocity right here is just v or u. Why we say so? You can put here u or you can put here v. Why? If it is a constant velocity, let's say starting it is at 10 meters per second. After a very long time also, if it is moving in the constant velocity, it has to be 10 meters per second, which means this is the initial velocity. This is the final velocity, if you can consider like that. But that final and the initial are equal, the same, right? So it is, I can put here u equals, or maybe the v, usually the u, it's going to be us over t. We have already derived this equation, s equals ut. That you can apply only for the constant velocity. That's the first equation, nothing fancy, we have learned it already. Okay, I think it's better we could derive them together. So let's try it like this. Let's consider the following parameters. Let's consider the following parameters for an object in motion. For an object in motion. Great. So we write this 5. Have you learned about this with the others? Kinematic equations? No? Okay. Great. Finally, something with the elements then. Okay, then we write the first one, if moving with a constant velocity, just underline that constant velocity thing, and like this. Great, now we'll move into the next thing, that is if moving with an acceleration, if moving, we'll write together, moving with an acceleration. We write with moving with A constant acceleration. That's better. So constant acceleration means the acceleration also could vary with the time, depending on how much you press the gas, right? The accelerator, the acceleration changes, right? But for the A levels, most of the time we need to deal with the constant acceleration, where the acceleration doesn't change over the time. For an example, the last example that we have considered, right? Moving with 5 meters, an object moving with 5 meters per square second, which hasn't changed over the time, right? හැම වෙලාවෙම තිබ්බ 5 meters per square second තමයි. So the velocity is increasing by 5 meters per second in each second. But this also, the acceleration also could vary. We are not going to consider it much, but there's a situation that we need to consider in the third lesson, and more specifically for the simple harmonic motion. By the harmonic motions, the acceleration changes with the time. Before that, you don't need to deal with the changing acceleration. So these equations are valid when something moves with a constant acceleration. Okay, so there we need to learn how we can specifically define the acceleration. So acceleration, we have considered it to be a change of velocity, right? Equals change of velocity divided by time. How do you write the change? කොහොමද අපි change එකක් ලියන්නේ? Yes. So you can consider the final velocity minus the initial velocity and divide by the time. That's the acceleration, right? So let's write these, or this, replace this with the the standard parameters. Acceleration, we are going to put a, that's equals to final velocity, that's v, minus initial velocity, that's u, over time, it's t. Well, it's not nice to be keeping like that, but okay, but we can just decorate this one a little bit, right? Not drawing flowers, but then you can multiply this one to the other side. So I'm going to have AT is equals to V minus U. So I can take this U to the other side too. So AT plus U is equal to V. In a nice way, we can write V equals to U plus AT. Great. This is the second formula that we are going to use. You're right. And it's better, guys, you could sketch this one. This is U and this is V and has been displaced by an S with the time t, and the acceleration to this side is a. Just make sure you write change of velocity is the final velocity minus the initial velocity, divide by time, and like this. Okay, great. Now, how do we write the displacement here, guys? If it is accelerating, how do we write the displacement? Usually we could write the displacement S equals ut. We have derived it from the first equation. But the thing here is, it was u earlier, but after a time it is changing to the v. So what can we put here then? Not the difference actually, we can take the mean value, right? It's changing from u to the v. So we can add them and divide by the 2. So I could do like this, S equals u plus v over 2 into t. In that case, because initially it was u, after some time it is v. So fit into the same equation, but instead of u, we need to put the mean here. And that is going to be the third equation. All this we are writing if the object is moving with a constant acceleration, right? You don't need to draw it once again. We have already, right? We just write the equation. Here just write, this is the mean velocity since the velocity change when accelerating. Okay, great. Uh, so I'm gonna have this as the second equation, which is v equals this thing, and I'm gonna have the v plus u over 2 equals to this. What I can do here is I can substitute the v there in terms of this. So I can write by 2, well, by substituting the 2, s equals u over 2 into t. For the v I can write like this, u plus at for the v. Well, you don't need to put the bracket here also, because we're gonna have just the addition, but I have put there to represent that this is the v. So s equals, then we're gonna have u plus u, that is 2u plus at over 2 into t. Um, yeah, so let's divide this each term by 2. I'm going to make a nice equation now. So it is 2u over 2 plus at over 2 into t. You can see the 2's cancelling off. So s equals to, and I can multiply this t to inside. So it is ut plus, this I can write in front, half a t squared. There's t already and there's t coming into it. And yeah, that's going to be the third equation. Now fourth. You can write by 2 substituting. So you can write subs and t like this. Some scientific abbreviation, right? 2, 3. Oh, you just right. Substituting to 3. Yes, exactly. Very good. So sometimes there are scenarios the final velocity is not given, initial velocity and the time acceleration is given. So you can use that. Okay? Great. So if you see all the equations that you have derived, what's the term common? Derive කරපු හැම equation එකකම common term එකක් තිබ්බා. For all the equations you need to have බලන්න හැම equation එකේම තිබ්බා time එක තිබ්බා. Right? So what if there's a moment where the time is not given? So we'll do a nice replacement by the same 2. I can subject the t from here and maybe substitute it to the third equation, right? Let's do it. I'm gonna, oh, let's just keep it. Italian, right? Okay. So by 2, by 2, I can have t equals time equals, which means I should bring this u to the other side, right? Maybe I'll write it from scratch. So v equals u plus at, u goes to the other side, so v minus u equals to at, so t is equal to then v minus u over a. And you can substitute it to the substituting to the third equation. You're going to have s equals to u plus v over 2 into t, which is this, v minus u over a. I think I have to erase this. I'm sorry, guys. But you know, right? So I'm gonna take it all the way up to here, right? Do you see a way to simplify this? Well, not like that, but if I just write it like this way, it's much convincing. I have like multiplied the denominators, that is 2a. So I'm gonna write like this. So you can see here it's v plus u, or else I could write u, like there we're gonna have u plus v, but I could write v plus u as well, right? Which is 2 plus 5 also equals to 5 plus 2, right? Interchanging the two terms, Besides the addition, we'll not change the value like that. And I'm gonna have this. Does this rings a bell? Yeah, we could write this one to be the difference of two perfect squares, that is v squared minus u squared over 2a. Luckily, we have already replaced the time, so there you don't see a t here. But it's again not nice, so we can make it to be nice, right? Cross multiplying this 2a to the other side, I'm gonna have 2as equals to v squared minus u squared, and I can take this to the other side too, so it's 2as plus u squared equals v squared. Decorate this one nicely. It's going to be v squared equals u squared plus 2as. So this is going to be the fifth equation. Okay, I told you we're going to be deriving 5 formulae. Here's the 5. That's the first one. Well, I have erased it already. That's just s equals ut, which only can be used for constant velocity. So you can start from here by 2 and substitute in 3 and voila, here. Okay. Great. Now, how do you like to spell this word? I can say it to be kinematic or kinematic. What do you prefer? Kinematics. What about you? Kinematics. Okay. That's you prefer the British accent, I guess. Then kinematic will be from the US, right? That means the American accent. There are different accents, right, for the English. So kinematic or kinematic, right? What do you prefer? Okay, fine, whatever, right? So the 5 formulae we have derived is also known as the kinematic equations for the linear motion, right? So we are going to write a summary then. Summary. You can write it, right? Summary. Kinematic equations of linear motion. කියලා දාලා අපි මේ පහ ලියාගමු. This is the best way you can remember it, guys. අර අපි derive කරගත්තට equations පහ අපි අර මේ විදිහට අපිට මතක තියාගන්න පුළුවන් ලේසියෙන්ම මෙන්න මේ order එකට ඔයාලා මතක තියාගත්තොත්. And this is the order that I have practiced. You can remember it like that too. It's okay, right? Order එකක් මතක තියෙන්න ඕනේ කොහොමත් එකයි. But at least you can have a sense, okay, I forgot the fifth one, right? That's why we just preferring an order. So usual one, it is the first one to be S equals ut. Second one is going to write v equals u plus at. The third one is s equals, can you fill the next one? Yeah, ut plus half at squared. Fourth one will be v squared equals, u squared plus 2as. And finally s equals to v plus u over 2 into t. Which means usually we have to use this three equation mostly, right? අපිට හැම වෙලෙම use කරන්නේ mainly මෙන්න මේ three equations තුන. මේක අපිට එච්චරම use වෙන්නේ නැහැ. කමන්නේ use කරන්න පුළුවන් අවුලක් නැහැ. And this one it's only used for constant velocity. ඒක අනිවාර්යෙන්ම මතක තියාගන්න acceleration එකක් තියෙනවාට මේ equation එක දැම්මොත් වැරදි. එතකොට මොකක්ද මේකේ හරි? කොහොමද ඒක හරි කරගන්නේ? If there's an acceleration, we have to add the rest of the part, right? For the ut, we have to add that half at squared to fit with the acceleration. This is only for constant velocity. ආය අපි එතන ලියාගෙන තියාගමු constant velocity කියලා. Right. So guys, I hope you guys all have a piece of sheet with you. තියෙනවද පරණ sheet එකක් මොකක්ද? rough sheet එකක් හරි මොකක් හරි තියෙනවද? Or at least you can write at the end of the book. මොකක් හරි පරණ කොලයක් හරි මොකක් හරි තියෙනවද බලන්න. නැත්නම් පොතක් ගත්තොත් වටේ අනිත් පැත්ත පිටුවේ ලියමු. මේ පොතේ පුළුවන් අන්තිම පිටුවේ ලියන්න. It's okay. You can use a pencil. හරි? So I need you guys to go through these 5 formulae once again and take a screenshot to your brain, right? And you're supposed to write it with the memory because this 5 formulae you need to remember until the death, right? Not for the A levels, right? So you're supposed to remember this one until the lifetime. So make sure you remember these 5. So again, this derivation part, it's not included to the, I mean, they are not asking you to derive in the exam these 5 formulae. Instead, you need to use them for a question given. So derivation part you don't need to remember. Derive I have done the derivation so that you know these are not some alien formulae, right? It's just derived from the basic physics. But you're supposed to remember the 5 formulae. You can go through what you have written there, not within the book, right? Maybe පොතේ ලියපු එක බලන්න. අර summary එකක් අපි හදාගත්ත නේද? ඒක බලලා ඊට පස්සේ you should write it by your own memory. No, order can be changed, but I find that this remembering with this order is kind of easier. But okay, it's okay, up to you, right? කොහොම හරි order එක මතක තියාගන්න ඕනේ. 5 formula කොහොමද මතක තියෙන්න ඕනේ. Right? You can refer your own summary that you have written there. I'll give you maybe 3 minutes, or maybe 2. To remember, right? Not to write. Thereafter can you? I think the time is sufficient. Now you can go to the maybe the end of your book or maybe in the piece of sheet, right? Without looking at the equations that we have derived, try your own to write the file. Okay. If you have finished only, you can go back and see whether you have done a mistake. මොන හරි මිසින් වෙලා තියෙනවා නම් ඔන්න ආයෙ හදාගන්න පුළුවන්. හදාගන්න ගාම ආයෙ කවදාවත් අමතක කරන්න දෙන්න දාගන්න, right? So without memorizing this one, you are not allowed to go for any exam from here after because for the linear motion, also for other types of motion, these 5 formulae are kind of really essential. Okay, great. Now let's do some questions. Come to the new tute and to the page 1. So page 1, you're gonna see we need to discuss these 4 stuffs for the motion. Actually, for the linear motion, you're gonna see above. අපි linear motion කියලා කිව්වට linear motion එකෙත් අපි we have to discuss 4 sections. One is the linear motion itself, the other one is the motion under gravity, the projectile motion, and the relative motion. And luckily, we have finished the first part, the linear motion. You can put a tick, and maybe it's like a game, so we have unlocked the first level now, right? Okay, so we'll move into the first question. We are not going to do it now, but you can do it as a homework. But let's see. A vehicle moves with a constant velocity of 5 meters per second. Mark the displacement obtained by each second in the following diagram. So you can see here u1, u2, u3, u4, u5, all the scenarios, the velocity is same 5 meters per second. How do you find the displacement? S1. S1 එක හොයාගන්නේ කොහොමද? It's a constant velocity, so you can put S equals ut, right? So think about it from the unit as well, guys. Velocity is the rate of change of displacement. Yeah, that is, right? You can see here 5 meters per second. That means 5 meters per second. For each and every second, it displaced by 5. That's the whole idea, if it is moving with a constant velocity. So S1 is also 5, S2 is also 5, S3 also 5, S4 also 5 then, meters. Right? Okay. You can do it at home. Moving to the second question, you can see a vehicle starts from rest and moves with an acceleration of 2 meters per square second. What that one implies? Each and every second, the velocity is increasing by 2 meters per second. So you can mark the velocities there, 0, then after 1 second it is, think about each and every time it will have to be 1 second, right? Each second in the following diagram. So it's t equals 1, t equals 2, likewise going on. So velocity will be 2, 4, 6, 8. How do you find the displacement then? We'll do it together. We'll mark the velocities first. Velocities blank key. U1 is 0. What are the velocities? U1 is 0 meters per second. U2 is moving with the constant acceleration of a equals 2 meters per square second. Okay. So it is what was it? Okay, 2 meters per second, 4 meters per second, second, and 6. Right? So we were wondering about the displacement. Huh? Okay, that's U5 answer, right? I haven't drawn it. Fine. So yeah, how do you find the velocity S1? Yeah, you know the time here, it is just basically 1 second that we are interested. So simply you can put S1 is equals to V plus U over 2 into T. That's really easy, right? Because we know the final velocity is 2, initial velocity is 0, divide by 2 into second, 1 second. Easy peasy. It's just 1 meter. Likewise, you can do, just do one. I need to get everything correct. ET paper තියෙන්නේ අද කොහේ අලුත් තැනක තිබ්බේ මනෝජ් සර් ET paper එකක් තියෙන කියලා ET paper එක අතනනේ පොතේ අතන ළමයි ටිකක් ඉන්නවා පේනව නේද ඔන්න මෙතනින් මෙතන බිල්ඩින් එකේ අව්ව ෆයිල් එක දුන්නේ නැහැ ෆයිල් එක තියෙනවා. ඔයා මෙහෙම පහලින් ගිහිල්ලා මෙහෙම රවුමක් ගිහිල්ලා අතනින් උඩට එන්න තියෙනවා. හ්ම්. The next one. So it's just 4 plus 2 divided by 2 into 1. Great. So you can do the third question, which is kind of involving the derivation that we have done, and the equation that you can obtain, you can write it here, blank. We are moving into the fourth question now. Fourth question, we'll try the first one. Dude, fourth question, first one. So out of that 5 formulae, think about a suitable formula or an equation that you can put to find the t first. With the given data, u is known, a is known, and v is also known. It's better you could mark a direction too, maybe drawing an arrow. For this one, it's not mandatory, but it's better to have the practice. Later on, we're gonna have some directions involving too. After you find the t, you should find out the s as well. So if you guys kind of can extract the data now, in this case it is kind of purely given u, v, a and t. But if you see the other questions like the question 5, 6 and so on up to the 18th one, you haven't given what is the u, what is the v and the accelerations and all, right? With this extracted data, instead that they are given in a statement wise. So you don't need to worry about it. Make sure you are writing what are the velocities, initial one, the final one, acceleration and the time and sort of what are the data given. If you write them like that, if you extract the data only, you can choose out of this 5 formulae which can be used to find the unknown parameter. Here again in the fourth question, they are specifically given. මේ ටික දන්නවා දන්නේ නැති එක t කියලා දීලා දෙනවා. In that case, you can quickly see that 5, not to see the 5, but better you can remember the 5, right? And you can use a certain equation appropriately to find out the unknown. If it is not given specifically, like the what is u, what is v, like that, statement wise questions වලත් මේ විදිහට ඒ අදාළ instant එකට මේ විදිහට ඒ data ටික වෙනම extract කරලා ලියා ගන්න. And for the unknown, just put a question mark. Then you know that's the thing you should find out, right? Okay, so stick with the first one. To find out the t with these given, you can use simply v equals u plus at. Again, all these are vectors, so it's better you could have a certain sense of it by drawing an arrow. Not to everyone, but you're supposed to draw arrows for everyone, or you just need to underline them, right? හරිනම් vectors වලට මෙහෙම underline කරන්න එපා. එක්කෝ උඩින් arrow එකක් ලියන්න එපා. අපි මේ දෙකම නැතුව we just mark a direction, which means you have taken this side is positive, which we have done already for the resolution as well, right? For the resolving, we have put to this direction x. Likewise, right? So අර පළවෙනිම question එක නිසා ඔන්න ලියන්න I have taken this side positive, this direction positive, this saying to yourself, also the one who's marking the paper, that you have taken that side is positive. That's why you just do an arrow like this. Again, for this question it's not mandatory, but later on we need to have that one to be exactly considering the direction. So yeah, it's to be 20, 0 plus a, that is 2 into t. So 20 equals to t equals to 10 seconds, right? Then you should find out the s, guys. S එක හොයන්න තියෙනවා ඊළඟට නේද? What's the equation that you can use there? Be careful. There's an acceleration here, so you won't be able to use the first equation, right? එහෙනම් මේ හතරෙන් එකක් තමයි දාන්න වෙන්නේ. Okay. So to find the s, you can use this one. What about this? Yeah, that also you can use. What about this one? That also can be used. මොකක්ද අපි ගන්න මෙතන? Yes. Okay, we'll take the last one. So v is known, is given as a data, u is also given as a data to time. We have found that one out, right? But guys, think about it. Say, let's say it's your bad day. So by doing the calculation, you got this t to be wrong. Then you are substituting a wrong value for this one to get the displacement, right? It's okay again. It's totally fine. You can get the displacement. You will given the marks if you use this one. But for the safe side, it's better we stick with the data and try to get a displacement within the data, right? Data විතරක් use කරලා time displacement එක හොයන්න පුළුවන් නම් it's more safe, right? Again, I'm telling you can use either one of these. මේක දාන්න පුළුවන්, මේක බෑ. හැබැයි මේ ඔක ඕන එකක් දාන්න පුළුවන්. අවුලක් නැහැ. ලකුණුත් දෙනවා ඔක්කොම හරි. But අපේ safe side එකට හොඳයි. Without substituting a value that we have calculated, try your best. If not, that's totally fine. But try your best to stick with only the data and find out the whatever the unknown. Here, it's better you could choose the fourth one, which is not involving the time that we have calculated, right? So I'm going to use that, and that is 20 squared equals 0 squared plus 2 into s. So that is 400 is equal to 4s. 400 cancelled off 100, so s equals to 100 meters. Again, you will get the same answer if you substitute it to here or maybe to this, right? But remember, it's for your own good, right? So either this get wrong, if you get this to be corrected, you will given the mark for this. තේරුණා නේද? මේක වැරදිලා තිබ්බ මේකට මාක් නැහැ. හැබැයි මේකට මාක් එකක් තියෙනවා. ඒක වෙනම calculate කරලා තිබ්බොත්, but if you use the wrong substitution, then you ended up with losing the both marks. Okay, let's try the fifth one, last one. I mean the fourth question, last part. Fifth part of the fourth question. අර මික්ස්ලා ඇප්ලිකේෂන් එකක් තිබ්බ පුරවලා දැම්ම සෙන්ටර් එකට. දැම්ම නේද? හෙටද ඉන්ටර්විව් එක තියෙන්නේ? ඔව්. මේ නුෂ්කා දැම්මේ නැද්ද? ඇප්ලයි කරේ නැද්ද? ඉංග්‍රීසි මීඩියම් එකද? එහෙමද? මම ඒක නම් හරියට දන්නේ නැහැ. මොකද කියාගමු ඔව් මම පොඩ්ඩක් අහලා බලන්නම් මිස් ඒ සර්ගෙන් මම අදම අහලා මිස් පණිවිඩය කියන්න දැන් අද යන්න දින්නේ ගෙදර හා 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 ඔව් කිව්වද නේද හා හා මම මේ හැඩ මිනිත්තු 12:00ට යනවනේ මම කෝල් එකක්ම දෙන්නම්කෝ මේ දැම්ම වගේ සර්ගෙන් අහලා කෝල් එකක් දෙන්න හරි හරි okay great කොහොමද ආවේ acceleration එක කීයද ආවේ 10 10ද okay 10 what cashews pebbles acceleration එකේ unit එක ලියන්න ඕනි හා නැත්නම් අර substitution එකට එක මාර්කයක් හම්බ වෙනවා final answer එකට මාර්කයක් හම්බෙන්නේ නැහැ right ඊට පස්සේ හරි what you got for the displacement 30 meters okay shall we try the 11th question really quick page 3 11th question Anushka නාවද මේ answers ටික මොකක්ද දවල් I found the S question no? 5 plus 25 can but again 5 plus 25 can 30 ne? by 2 is 15 into 2 seconds this is seconds not 5 yeah S එකයි බහයි බැටලා දෙයි හරි නේද හදාගන්න පුළුවන් නම් shape එක හරි ඊළඟට දැම්මේ v squared equals c squared plus 2 හරි alright ඔය එක දාන්න පුළුවන් okay 11th one you could sketch it maybe a diagram and extract the data from that No, it is a deceleration, so better you mark it to be minus, right? Acceleration එක නෙමෙයිනේ deceleration කියන්නේ opposite of acceleration කියලා කිව්වේ අපි. Right. It's like this, guys. What's the reaction time? I guess the bio guys knows about that. Reaction time? Yeah, 0.5 seconds. What exactly the reaction time is? So I have just drawn the scenario like this. Okay, now this guy is driving very peacefully and sees the goat, right? So what he need to do? He first need to see that, which means the light has to be fallen to the retina, and that the nerve pulse has to go to the cerebrum, and the autonomous nervous system has to work, and maybe he need to grab the wheel and also press the brake. That's the reaction time, guys. Which normally for a person it is 0.5 seconds, but if somebody is drunk and drive, right, that's the disaster there, because the reaction time increases. He sees the stuff and takes a longer time to react. Within that time, what happens? Still the vehicle is moving with that 20 meters per second. After he apply the brakes only, he can like that come to stop. So within that 0.5 seconds also, the vehicle moves. So if you need to find out how far the accident has to be seen, which is the entire this distance. And this part right here is moving with a constant velocity. Still, it is moving with a constant velocity 20 and 20 until he apply the brakes. Once apply the brakes, it's moving with the deceleration. So this is the S2. S1 you can find out very easily. It's to this direction. S equals ut. Why? Constant velocity, right? 20, 20. S1 equals 20 into 0.5, which is S1 equals to, that's 10 meters. From thereafter, you can find out to this direction S2. Come on, what are the data you know? Now you can extract. U initial velocity is 20 meters per second. Final velocity 0. It should stop, right? නැත්නම් goal වදිනවා. Final velocity එක v කියන්නේ 0 වෙන්න ඕනේ. See, it is not given, but we should think about it. What else? Acceleration also, you know, it's not an acceleration, it's a deceleration. So minus 5 meters per square second. You should find what? S, which I have taken as S2, then to the same direction, guys. මේ පැත්තටම අපිට පුළුවන් S equals මොකක්ද හොඳ? S හොයන්න බෑ නේ එකපාරම නේද? මේ තියෙන data එක මොකක්ද හොඳ? Out of that 5, something without involving the t. Yes. Can you tell me that? V squared equals u squared plus 2as. Final velocity is 0, initial velocity 20 squared plus 2 minus 5. Why minus? To this direction, it's a deceleration into s2. So it's minus 10 s2, so it's 400 minus 10 s2, that's 0. This taken to the other side, 10 s2 is equal to 400, cancelling off, so s2 is equal to 40 meters. Therefore, you can write within the driver. You write it very quickly, right? Because you need to go to catch the bus. Therefore, driver need to see the accident at a distance of s equals s1 plus s2, which is 10 meters plus 40 meters, altogether 50 meters. Better you sketch it, right? මේටික ලියාගෙන අරකට ඉක්මනට අඳගන්න. I'll make sure this video will be available very soon. You can within this week, right? For sure. Last week මම සෑහෙන occupied වෙලා තිබ්බ projects එකයි අර ඔයාලගේ අපේ තිබ්බනේ මොකද්ද? Initial මේකක් ඒක ඔක්කොටමත් එක පොඩ්ඩක් මේවා තිබ්බේ. ඉතින් මේක ආයෙ පාරක් බලන්න හොඳයි. අන්තිම question එක අපි කරේ කොහොමද කියලා ආයෙ පාරක් බලන්න වීඩියෝ එකේ. And as the homeworks, you can try the questions all the way up to 18. 18th one එකනකම් homeworks කරන්න පුළුවන්. Also the MCQs are there. You can try the MCQs from page 15. Page 15 question 1 ඉඳන් page 17 question 27. Page 15 question 1 2 page 17 question 27 වෙනකම්ම කරන්න පුළුවන්. Right? Great then. So again, thank you for joining the class today. Have a great week.